Time value of money functions, part 1. In this section, we'll be looking at computing present value and or future value, solving for rates, and dealing with different compounding frequencies. Before we begin with time value of money, it's very important that you be familiar with the acronyms that are used on your calculator. Here are a list of the acronyms you should be familiar with, starting with N, which is number of periods, commonly misunderstood to be the number of years. But again, it's number of periods, where periods could be years, months, weeks, and even days. I by Y, interest per period. PV, present value. PMT, payment per period. FV, future value. When you're working with time value of money questions, it is very important to keep two things in mind. Number one, always clear your calculator memory after every question. To do this, you need to press second, the yellow button, and clear TDM. The purpose of clearing your calculator memory is to ensure that any previous calculations do not interfere with your current calculations. The second thing to keep in mind is that when you're entering data into the calculator, it's always number first, and then you assign the number to the respective time value of money key. Let's take a look at examples on how to do this. Our first example would be to compute present value. Jack wishes to buy a house in the Bahamas and needs to save USD 8 million in 10 years. Assume that the market interest rates are expected to be constant at 6% compounded annually. How much money does Jack need to invest today to buy his dream home? Before we begin with such a question, it's very important to gather all the information that we'll be needing to enter into the calculator. For example, 8 million is the amount of money Jack needs in the future to buy his house. 10 years is the time Jack has to save up money. 6% is the rate of interest that Jack can earn on his funds. Now that we have all of this information, we're ready to key it into the calculator. But before we begin, remember to clear your calculator memory. To do this, you press the second, the yellow button, and clear TDM, which is the FV button. Now, we begin with typing in 10. You will assign it to N. Then you will type 6. Press the I by Y button. Then you will type 8 million. You will press the future value button. And then you will press compute, CPT, and present value. You should be able to see an answer of $4,467,158 is the amount that Jack needs to set aside today to be able to save up for his dream home in 10 years' time, provided that he's earning a rate of interest of 6% each year. The order in which you assign values to the time value of money buttons does not matter. You may have started by assigning the 6 as the I by Y, 8 million as the future value, and then 10 as N. What is important is that you enter the number first and then press the relevant time value of money button, and at the very end, compute the desired value. Let's take a look at our next example, where we will be computing the future value. Amanda deposits 60,000 euros today in a savings account earning 5% per annum. Determine how much her account would grow to in 7 years' time. Once again, before we begin, we gather the relevant information. 60,000 is the amount Amanda has today. 5% is the rate of interest she can earn on her account. 7 years is the time she has to grow her money. We will begin by clearing the calculator memory. Go ahead and press the yellow button, second, and clear TDM, FV. Now, we will key in the numbers 7, press N, 5, press I by Y, 60,000, assign it to present value. You are now ready to compute your desired outcome. You will then press CPT, which stands for compute, and then future value, FV. You should be able to see an answer of 84,426 on your calculator. This is the amount that Amanda will have in the future after 7 years of investing. In some cases, you could be provided both present value and future value. When dealing with such a question, you might be asked to solve for the rate of return earned between the present time to the future time. Let's take a look at an example. AA Corp had recorded sales of 3,809 million by the end of 2016 and recorded sales of 4,180 million by the end of 2020. Determine the per annum compounded growth in sales over the 4-year period. In this example, the sales of 2016 is what AA Corp had at the beginning, which was 3,809 million, therefore the present value. Over time, the sales had grown to 4,180 by 2020, thereby being our future value. When working with both present value and future value, it is important to remember that your calculator operates on an inflow-outflow method. That means if one amount is provided as a positive, the other amount has to be a negative. So if we assign the present value to be negative, we must keep the future value as positive. This is because the calculator understands that to invest today negative present value, we will get a return in the future, a positive future value. What happens if I do not follow the positive and negative rules? That is making sure one of the items, either present value or future value, is negative. Well, then in that case, your calculator will throw you an error 5. Keeping this in mind, we'll go ahead and solve the question. We will begin by clearing the calculator memory. That's second, clear TBN. We'll type in 3809 and press the plus minus button at the bottom to the left of the equal to sign, and then we'll press present value. We'll type 4,180 and assign that to future value. We'll press 4 and assign it to n. We will then compute the I by Y. The answer is 2.35%. This means that the sales of AA Corp has grown by 2.35% each year for 4 years. Working with varying compounding frequencies. Interest rates are always reported on an annual basis. Candidates must convert the annual interest rate into a periodic rate. To do this, you will take the annual rate and divide it by the compounding frequency. To keep the inputs consistent into the calculator, candidates must also convert the years into periods. To do this, the candidate will take the total number of years of investment and multiply them with the compounding frequency to obtain the number of periods. Let's take a look at an example on how to work with this. James purchases an investment for £20,000 that promises to pay an interest of 6% per annum compounded quarterly. How much money would James have accumulated over 3.5 years? 20,000 is the amount that James has today. 6% is the rate of interest that James would earn compounded quarterly, and 3.5 years is what James has to compound his money. We will begin by clearing the calculator memory. Press the second, clear TBN. We'll begin with the number of periods. So we must first type in 3.5, press the multiplication sign, multiply by 4, because there are 4 quarters in a year, and press the equal to sign. We will then assign this number, 14, to n, so press the n button. We'll then move over to computing the periodic rate. We'll type 6 on our calculator, press division, and type 4 and the equal to sign. This will give us a 1.5% quarterly interest rate, which we can then assign to I by Y. We will then type 20,000 and place that into the present value button. We can then press compute and press future value. With this, you should be able to see 24,635 as the future value on your screen.